In the course notes, when we were looking into the variational eigenvalue problem related to the magnetic field, at some point we arrived at an equation and then we told you, okay, this equation can be transformed into that equation over here. So the purpose of this exercise is to show that you can indeed do that. And just to be absolutely clear which equation needs transforming, let's just copy that equation again from the notes. So it's delta H Hj plus H delta H j plus H delta j. Okay, that's the left hand side. And then for the right hand side, we have H theta operating upon delta H plus delta H theta H. Okay, so pause the video here and see if you can transform this guy over here into that expression over there. The first thing that's helpful to realize is that this expression over here, that's basically just our variational form, right? So this is J, so this will save us some writing here. And now that we know that, let's calculate our delta J according to that formula that we had up here. So where do we have the formula? Over here. So let's now fill in what we know about G in that expression here for delta J. So delta J becomes, so one thing you will notice is that we have these 1 over HH everywhere. So let's first write that. So it's 1 over HH. And then the factors 2 over here and 2 over there will cancel. And let's now calculate the delta H with G. So let's see what that gives us. For the first term, we get then a delta H theta H. And then for the second term, we have minus J. And then we have an H here on the right-hand side. So this will become delta H H. Okay, so this was taking care of what we had up here. Let's now look at the second term. So that's G delta H. So it's basically just exchanging the order here. So this will become a theta H delta J minus J H delta H. Good. That looks a lot like that equation that we had up here. So let's try to simplify this a little bit so that we can more easily show that they are indeed equivalent. The straightforward thing to do here is to bring that guy to the left-hand side here, so that we have then delta J H H for the left-hand side, and then for the right-hand side we have two terms which do not involve J, namely delta H theta H plus theta H delta J. And then we have two terms that do involve J. So we have minus J delta H H minus J H delta H. Okay, let's see if these two are indeed equivalent. So the first thing to look for is this term here involving delta J. Now this term delta J is the one that we find up here, so that's good news. Over here on the left hand side over here we have two terms involving J. So these will be these two terms that we bring to the left hand side. Now if we look at the correspondence here, the factors in front of this J, that looks fine, so indeed they correspond. And then for the right hand side over here we have these two guys that should correspond to these two guys, which is almost true. The only thing that would need to happen is that we would need to move this theta from operating upon the second factor to over here where it operates on the first factor. Luckily, we can do that because that's precisely the definition of a Hermitian operator. So once we move this guy to over here, then indeed we've shown that these two equations are indeed equivalent.